A fun problem today. I'm writing down a few initial conditions that have to hold up before we can proceed right here. Now, I'm not assuming that x is greater than or equal to 0. It's a consequence of the left-hand side of the equation. Okay. What we're trying to do here, folks, is find an upper bound on k, on the variable k. It's a real variable, and we're trying to find an upper and lower bound on it. That's what we mean by imposing constraints. Now, this condition right here is true because the left-hand side is composed of two square root functions, and a square root function has a range greater than or equal to 0. So this is not an assumption, it's a consequence. Okay, now under that, laboring under that consequence, we can square away here like normal. So this is one of the usual forms that you use, a plus b quantity squared. Now, a plus b quantity squared is well known to be a squared. Now, there's already a 2 right here, so this is already in the form 2ab right here. And then, of course, this guy right over here is b squared. All right? And now the next piece of this is just collecting like terms, getting everything on one side, isolating the radical, I think is how some people put it. Now, what we get afterwards, we get a similar consequence. Just like x is greater than or equal to 0 up here, this entire piece right here has to be greater than or equal to 0. Okay, for the very same reasons, because the left-hand side is a radical square root function with a range of greater than or equal to 0. Now, it still includes the parameter k here. All right. Now, laboring under this assumption, which comes in very important later on, we're going to square both sides. And I won't bore you with all the details. It was very messy. I made 2 or 3 mistakes before I got it straight. Now, going from here to here, I thought it would be advantageous to divide by 16. Not necessarily the best way, probably, but a way. And you'll notice that you're going to end up with a quadratic. You're going to end up with a quadratic because you see you have these x to the 4th right here. X squared times x squared is x to the 4th. This is x to the 4th, so they go away. And you end up with a quadratic expression, which is nice, okay? And so we get right down to here, folks. Now notice, remember early on, we know that x can't be negative, and so we can scratch this part out right here. That's a no-go right there, all right? I don't know what to do about that, but no can do, folks. It's just going to be a plus solution, right? Now, this piece right here came kind of unexpected to me, but notice that you can rewrite this condition, this important condition right here, differently, of course. You can write this as 36 plus k as greater than or equal to 4x squared. Now, first, for us to have made it this far, we have to honor this condition. And we have to honor this condition, and so that's exactly what's going on down here. Guys, you can see right here, all I've done is recopied this, okay? And the benefit of doing that is we know what x is, right? We know what x is from this quadratic work we did. And when you square this object, you end up with this object. And you guys can verify that if you want, but I double checked it. Again, when you square this object and multiply it by 4, you end up with this expression right here. Okay, this rational expression. Didn't show that work, it gets too messy. Okay, let's keep going. Now the rest of this, folks, is just inequality processing. Okay, you can see right here what I've done. Our 4x squared was kind of our slave. And so we multiplied through by 18 minus k. And we got this expression right here, this inequality, excuse me. Now the rest of this is just multiplying things out and getting things together, okay? And so I'm not going to go through all those details. But when you do that, a nice thing happens right here. You get a nice factorable circumstance right here. And so this is equivalent, and you guys can do the sign analysis on this. but this is our solution right here. We have a lower bound 0 for k and an upper bound 12. All right. I thought it's really cool. So k can range between these two constants, and when it does, this equation will have real solutions. Anything outside that range, I don't know if they're even complex. It just doesn't exist, you know. But anyway, what I did for you guys is I worked just one example here. I arbitrarily chose k equals 6 right here. K is equal to 6. You can see I put the 6. Did that disappear on us? Here's our quadratic right up here, folks. So I just put a 6 right here, a 6 here, and a 6 here. And you do some work here, and it looks like this thing will simplify. 15 over 12, doesn't that reduce to, let's get some space here. 15 over 12 has common factors, so what is that, 5 over 4? So 5 root 6, if you must, who cares, yeah. But 5 root 6 over 4 is what that fraction of 15/12 would reduce to. But again, y'all, this is just an example for a particular k that's in this range. 6 is definitely in this range. But y'all, this is the answer to the question. Here's the original question. What condition do you have to impose on k in order for this expression to have real solutions, non-complex solutions? And I don't know if it even has any complex solutions. I'm not sure really. But anyway, this is the answer. Hope you guys enjoy.